Hi guys, my name is Trevor Sullivan and welcome back to the Stratus Grid video channel. In this video, we're going to explore a really interesting software development and cloud topic that helps you to deploy Rust applications as containers into an AWS account using a serverless approach. Now, for starters, we don't really deal with technology just for the sake of dealing with technology. We always try to align technology to business needs or business challenges, right? One of those business challenges that we often come across is modernization and cost optimization of cloud-based workloads. And we also sometimes encounter on-premises applications that need to be migrated up into the cloud before they can be modernized or as part of the effort to modernize an application. So our objective here isn't just to build a Rust application and deploy it in the cloud, but to really take advantage of the performance efficiency benefits that Rust applications have, as well as the developer velocity that you gain by using a container-based deployment approach. Now, you'll be able to replicate the steps that we learn in this video in your own environment, as long as you have an AWS account and the other tools that we're going to talk about here shortly. So make sure that you kind of understand this end-to-end process and then customize it to your heart's content for your own application deployment pipelines in AWS. We also have a product here called Stratosphere, which is basically a dashboarding tool that helps you to find cost savings opportunities within your AWS account portfolio. When you're managing lots of different AWS accounts, it can be really challenging to find where some of your highest spends are in the cloud. And so this tool called Stratosphere helps you to identify where those optimizations can be found. And that helps you ultimately to improve the efficiency of your business in the AWS cloud platform. So we're going to be taking a look at how to use the AWS Fargate service here in particular, and there is a corresponding written blog post, so if you'd prefer to read through the steps rather than watch through this video, or if you'd like to kind of use them in tandem together, feel free to read through that as well, and that'll have all the code samples that I'll be using for things like Docker and Rust and all that fun stuff. But ultimately, our target compute environment here is going to be the AWS Fargate service. Now, why would we want to use AWS Fargate? Well, at the end of the day, we care about running business applications in the cloud. There's some set of functionality that we want to build in software and then publish or deploy so that our end customers can gain access to that application. And AWS Fargate is just one of the many different compute options that you have available in the AWS cloud. If you look at other cloud vendors, they actually have competing solutions similar to AWS Fargate. For example, in Microsoft Azure, they have Azure Container Instances, which is kind of a serverless platform to just spin up containerized workloads. Also, Google Cloud Platform, GCP, has the Google Cloud Run service, which allows you to take a container image that has your application packaged up inside of it, and then simply deploy that as a container to your GCP account. So AWS Fargate is certainly not the only service of its type. There's also lots of smaller vendors that are out there like Railway or Render.com or Northflank. All three of those are very container-centric deployment platforms that allow developers to iterate quickly. But we're going to be using AWS Fargate here because as an AWS partner, our company is primarily focused on AWS workloads. Now, AWS Fargate is great because we don't have to worry about managing the operating system. Like with a virtual machine that you run in the Amazon EC2 service, you actually have to manage the infrastructure. You have to periodically run security and reliability updates on your software. You also have to do some observability around that infrastructure just at the virtual machine level to make sure that the virtual machine is healthy, that there's enough storage and all that stuff. So by using Fargate, we can kind of abstract away all that infrastructure. We can simply take a container image that has our application code inside of it and then hand that off to Fargate so that Fargate can run it for us. Now, you do still need to think about the networking aspect or the virtual private cloud aspect of networking for your AWS account in order to use Fargate, but at least we don't have to worry about managing virtual machines. There are also some other services that you might want to take a look at in the AWS platform that deal with containers. For example, AWS Lambda actually supports container images for launching serverless applications. You can also use the Amazon Elastic Kubernetes Service, EKS, and you can also just run containers on an EC2 instance itself. And then there's another more recent service called AWS App Runner that allows you to publish web applications and web APIs using a container-based approach. But I would say AWS Fargate is kind of the star of the show, so that's why we're going to focus on the Fargate service for deploying our Rust application. Now, let's talk a little bit about Rust. Why should you use Rust as a programming language? Maybe you're already a Rust developer, and so you already know the benefits of it, but if you are currently a programmer in another language, or if you're just picking up programming for the first time, the benefits of Rust may not be abundantly clear. So Rust is a very high-performance language. It's a low-level systems programming language that's very similar in performance to C++. However, you get a lot of automatic memory safety with Rust, which makes building applications in Rust much easier than using a language like C or C++. So if you're looking for a high-efficiency, high-performance language that allows you to pack a lot of density, a lot of clients accessing a single or fewer instances of your service, then Rust is going to be an excellent choice so that you get the best efficiency for the cloud spend that you're provisioning in your AWS account. So something else about Rust is that because it is a high-performance language, there's actually some benchmarks out there that have been provided by a community member. So this website is called maxday.github.io/lambda-perf, and this gives you a breakdown for various Lambda function sizes, certain memory allocations and virtual CPU allocations, as well as even the Intel AMD 64-bit platform versus the ARM 64-bit platform. It actually shows you, just in the US East 1 region here, what the best cold start times are. And as you can see, by a very wide margin here, about a 3x margin here, you can see that the cold start time for a Rust application benefits over something like Golang, which actually has a little bit of a runtime overhead to it. So that's about 3 times slower than Rust, and Rust is even faster in this case than C++ as well. So you can kind of look around at some of these different metrics that are periodically updated, but you're pretty much always going to see Rust at the top of the chart here. So this is a great justification to learn the Rust language so that you can build the best performing and best efficient applications in AWS and other cloud platforms. So now that I've kind of convinced you why you should use Rust and AWS Fargate as your language of choice and deployment target, we're going to actually step through the process of building a very simple API. It's not going to do anything terribly special, just kind of generate some random data. We'll package that up as a container image on our local development system here, and then we'll push that application up to the Docker Hub so that we can deploy the Rust application on the AWS Fargate service. And if you're interested in talking to us further about application modernization or cost control in AWS or anything like that, feel free to go back to stratusgrid.com and just look for the Let's Talk button over there, or on the homepage, you can just click on the Book Free Consultation Now, and that will allow you to find a time that works for you to talk with one of our business development managers. All right, so the first thing that we're going to need to do is to actually take a look at getting our local development system set up for starters. So if you head over to the Rust website, which is rust-lang.org, you're going to need to install the Rust toolchain. The Rust toolchain includes tools like the Rust compiler, the cargo CLI, which is used to install third-party dependencies from the crates.io registry. That's basically where Rust applications find their dependencies by default, unless you're using a private internal corporate registry. But there's a nice button up here called Getting Started. This kind of talks about how to, play around with Rust online if you don't want to install it locally. There's a script to install Rust in a Linux system as well. And so this just kind of helps you give some resources that gives context around the Rust ecosystem, including things like IDEs or integrated development environments. We're going to be using Microsoft Visual Studio Code, but there are lots of other tools as well. And this really just gives you kind of the base set of steps that you need to run through in order to build a new application. And then there's links to other resources like the cargo book that talks about dependencies. There's also a lot of other resources available. So make sure you check out the Rust website at rust-lang.org to install the Rust toolchain and get started. Now, I've already got the Rust toolchain installed on my local Windows 11 system here. So if I fire up a shell right here and just run something like rust c -- version, you can see that I've got the latest version of the Rust compiler. Also, you should be able to run cargo -- version, and that should show that version there. If you're looking for just the kind of simple one-line command to install the Rust toolchain, go to the website rustup.rs, and that is the landing page that's always going to have this little one-line script that you can use to execute an sh script that will install the Rust toolchain. You just exit out of your shell, restart your shell, and then cargo and the other Rust tools should be available on your shell path. All right, so once you've got the Rust toolchain installed, one of the other tools that we're going to need access to is, of course, Microsoft Visual Studio Code. So if we go over to code.visualstudio.com, this is the landing page right here for Microsoft Visual Studio Code. This is an awesome editor. It's cross-platform. It's extensible. It works really well with Rust because there's actually a Rust programming extension that you can install called the Rust Analyzer extension, and that really helps you to write Rust code more efficiently. So make sure you get VS Code installed on your dev system as well. Also, we're going to need Docker Desktop here because we are actually going to be building our container image locally on our dev system and then pushing it up to the Docker Hub registry to host that container image so that we can deploy it to AWS Fargate. So make sure that you download the Docker Desktop application. It does work for a variety of platforms such as the Windows platform as well as Mac OS, using either Intel or ARM-based CPUs, as well as for Linux. So this is a great cross-platform tool, and it'll install everything you need from the Docker containerization perspective. Now, I've already got Docker installed locally here, so if I go ahead and just do a Docker version command right here, of course, I need to actually fire up the engine here so I don't get this error. Sometimes I just stop the virtual machine to save on some system resources here. But once the engine is actually up and running, I should be able to do a Docker version command and just see that I'm successfully connected to the local Docker engine running in my Docker desktop environment. So we'll give that a second to start up right there and then talk about the last tool that we're going to need, which is a registered account with AWS. So you'll, of course, need to have an AWS account that you're logged into, and you're also going to want to register an account on the Docker Hub so that you can publish your own repositories containing container images that you publish from your local development system. So with all that tooling installed, let's go ahead and actually build a Rust application locally. Then we'll package it up and push it up to Docker Hub and deploy it to the AWS Fargate service. So we're going to be using this web framework here called Actix. And Rust doesn't really include a core web framework necessarily. I mean, you can technically build an HTTP server without using a framework because, of course, those frameworks are built on the core standard types in Rust. But we're going to be using this Actix framework here, which is one of the most popular web frameworks for Rust. And if you head over to the documentation and go to basics and then getting started, this will actually show you the example code of how you can define different HTTP routes using different HTTP methods or verbs like get, post, put, delete, option, all of those different things. You know, head is another one. And then you can define these routes as well as the asynchronous functions in Rust that are going to fulfill requests that are targeted at that particular route. So this is just some really simple code, and then we just define a main function down here. With actix-web, you do need to have an asynchronous main function, but that's really easy to do just by using the actix-web main macro right here, and that'll turn your async main your main function, I should say, into an async function so that it can execute the Actix HTTP server, and that HTTP server binds to a particular IP and port. You can, of course, use 0.0.0.0 to bind on all IP addresses or all IP interfaces, and then you can also specify a port number in this tuple here. And then inside of the body of that HTTP server, we can define one or more applications that contain different routes that we want to route web traffic to. So that's kind of the basic structure of what an actix-web application looks like. So for starters, what we're going to do is spin up a new application locally. So here's our Docker version output. It shows our version of our server and everything. So I'm going to go ahead and create a project directory here. I'm actually going to do cargo new, and we'll call this Stratus Grid dash actix. All right, so now we've got that, and then I'm going to do code Stratus Grid Actix, and that'll open up a new VS Code editor inside of that directory so we can start building out our application. Now, in Rust applications, you're going to have this cargo.toml file. This is your metadata file that describes your application here. And by default, you're not going to have any dependencies, right? So we need to make sure that we actually install the actix-web framework so that we can take advantage of the functionality that it provides for building web APIs and web applications, right? So again, if we go back to the documentation here, the way that they show you to do it is just to add that in under dependencies. But another thing that you can actually do is just use the cargo CLI. So back in our terminal, we'll say cargo add, and then say actix-web. Just want to make sure that that's the right name. And of course, we'll go into our project directory first before we run that, otherwise it won't know where cargo.toml is. And so now we've got that installed into our project. And if we go back to our VS Code window right here and take a look at cargo.toml, you can see that Cargo has automatically added that dependency for us. So now that we've installed that crate locally in our project, we can now reference the actix-web framework inside of our main.rs file here. Now, just to save a little bit of time, I'm going to go ahead and just copy in some code here that I've pre-written. And so what we're going to do is start by referencing the actix-web crate as an alias called AW. So anywhere that you see AW in my code, that's just a kind of shorter prefix alias that I've assigned to actix-web so that I don't have to type out actix-web every single time. And so what's happening here is that we're defining a new get route with the get verb in HTTP, and that's going to have a path, a URL path in your query string of new UUID, right? We also need to have our main function that actually spins up the HTTP server. So I'm going to go ahead and copy over my main function code, which is almost an exact replica of what you're going to see in the actix-web framework documentation. And so as you can see, we're applying this macro here that allows our async main function to be asynchronous, because normally you can't have an asynchronous main function unless you have an async executor in your Rust app here. And you can also see that I am binding to all network interfaces by using quad zeros for my IPv4 address. And then I'm also just going to bind to some random port like 18163 here. You can pick any port number that you want, like maybe 45678, something like that. And as long as that port's free, then you should be able to route to it. But I'm just going to stick with the port that I'm using in the blog post. So go ahead and just save that main.rs file. We only have one route defined here, so we don't have a home route, which means you can't just go to the IP address of the container on port 18163, you actually have to append this /new UUID path in order to go to that particular route. If you just do / here in your browser when we deploy this application, you're going to get a 404 because it can't find a route to send that request to. So let's save this application. And then the next thing we want to do is to actually just test it out locally. So what we'll do is say cargo run from our terminal here in our project directory. This is going to compile our application and then launch the web server, and we can test the application locally before we package it up into a container and publish it into the Docker Hub. So after all of these dependencies get compiled here, we're going to go ahead and test it out. And one other thing that I forgot to do is to install the UUID package. So because we are generating a random UUID right here, just a universal unique identifier, we also need to do a cargo add UUID. And then I'm using a specific feature here called v4. It's just a v4 UUID. And so we're going to run cargo add UUID -- features equals v4. And that'll make sure that we also have that dependency in our application. So with that fixed and that dependency added, we'll just do a cargo run here. And then we're going to see that we get our firewall complaining because we're trying to listen on a particular port. So of course, I'm going to allow that. And now you can see that we just print out starting web server here, and then the terminal completely hangs because we're basically just waiting for inbound HTTP requests at this point. So what I'm going to do is access my local host. So let me fire up a browser here, and we're just going to go to localhost on port 18163, and we should receive an HTTP 404 error message because we don't have anything responding at the root here. But if we plug into the URL /new underscore UUID, then you should see that a new universal unique identifier has been generated, and that confirms that our application is working correctly. So now that we know our application works correctly locally, it's time for us to go ahead and package it up into a Docker container image so that we can push that up to the Docker Hub for deployment to AWS Fargate. So the first thing that we are going to do here is to create what's known as a Docker file. Now, we are not going to be using some best practices here for production grade container images. I am purely doing this for development, but what we're essentially going to do is copy in our project directory into the containers file system, and then we're going to compile it on the fly when the container actually starts up. So the way that we are going to do that is by starting with the base Rust container image here. So we're going to use this from instruction to indicate that we want to start with a Rust container image that already has Rust pre-installed inside of it. That's provided by the Rust Foundation. Then we're going to set our working directory here. I typically, by convention, just use /app because it's short and easy to remember, but you can use whatever working directory you want to inside the containers isolated file system. Then I'm basically just adding all of the files from my local project directory into that. And then finally, I'm just doing a cargo run, just like we did locally here, in order to run the application. And that's the entry point for that container anytime that a new container starts up on AWS Fargate. So every single time that we spin up a container, it's going to recompile. Again, that's not necessarily a best practice to have your application code in the container. Typically, you're going to pre-compile the application and copy the pre-compiled binary into a production grade image. But in this case, we're just going to kind of keep things simple and copy in our project this way. So now we've got this Docker file, and what we want to do is run a Docker build command in order to use these instructions and actually build a container image locally. So let's do a Docker build X. Then we're going to specify a tag. I'll call this stratus grid -UUID. Or maybe let's call it actix, because that's what I named the project here. And then we need to specify what our context directory is. So let's go ahead and do a period here. And then we also need to specify the subcommand to build X here. So Docker is kind of moving from the Docker build to the Docker build X command. It's just kind of a newer processor for building out your container images. So we actually do need to specify the build X build command. So what we're going to do is just go back here a little bit and say Docker build X build, specify our tag and our context directory. Now, as you can see, all of those dependencies are getting copied into the container image. So that is really bloating up the container image. Again, that's generally not a recommended approach. So I'm actually going to do a cargo clean operation here to clean out that. And then we are going to rebuild that container image so it's a lot slimmer than it would normally be. All right, so now we've built our container image. Now what we need to do is create a repository in the Docker Hub and log into the Docker Hub from our Docker CLI here, and then push this container image up into the Docker Hub. So what we are going to do is head back over to Docker Hub. You should have already registered an account. We're going to hit create repository and give it a name like stratus grid -actix. And we'll give it a description like this contains a sample Rust application developed by Stratus Grid. And then we're going to make this public. So normally in a proprietary application, you're going to want private repositories, but generally you have to pay for those. And so because we don't have any proprietary code, in this case, we're just going to hit create here. This is just a sample application. And so then we're going to need to authenticate to the registry before we can actually do a Docker tag and a push command to push the container image from our local dev system up into the Docker Hub. If you head over to account settings in the Docker Hub, and then you go down to the security section, you can generate what's called an access token. And that access token is essentially your password to authenticate to the registry here. So what we're going to do is go down to the security tab. So we'll go down to the security tab, click on new access token, and then we'll call this stratus grid actix, and then you need to make sure that it has write permissions at a bare minimum because that's going to allow the Docker engine to actually push the container image up to the registry. So we're going to copy our access token here and then come back to our terminal. We'll say docker login, and we also need to specify -u and then specify your username. So we're going to go ahead and specify our username here. So do docker login -u Trevor STR. And then when you're prompted for your password, you'll just go ahead and paste in the access token that you copied from the web UI, and that should get you authenticated to the service. All right, so after you have generated an access token on the Docker Hub, you can go ahead and use the command line to authenticate. So to do that, you're just going to run a docker login command, do --username, and then specify what your username is, and then you'll be prompted for a password when you run that command, and you can go ahead and just paste in your access token. Now, I've already authenticated, so I'm just going to do Control-C to cancel out of that, and now what we need to do is to tag our image that we've generated locally into the repository. So basically, we're just renaming it from having a local name to having a name on the remote registry, and then we can do the docker push command that actually deploys that image or publishes it up to the Docker Hub registry. So to do that, we're going to do a docker tag command. Let's do a docker image ls for starters. So we're going to take stratus grid actix, and then we're going to say docker tag, and then specify that stratus grid actix container image, and then we'll do docker.io. That is the DNS name of the Docker Hub registry. Then we'll do slash our username, which is Trevor STR, slash the name of the repository that we created, which should just be stratusgrid-actix. So let's do stratusgrid-actix here. So that'll tag it. And then if we do docker image ls again, you can see that we've got this one right up here that is tagged into the Docker Hub registry. So now we can just do a docker push command on that docker.io/trevor_str/stratusgrid-actix, and that will push it up into the container image registry. Now, the nice thing about using containerization here is that all of the image layers that already include Rust pre-installed from the Rust container image, we don't have to re-push those up to the registry because they already exist on the registry. So the only two small layers that we have to push are the layers that contain our actual application code, which are pretty minimal in size, right? So that process is going to be really fast in order to push that up. So now what we can do is go ahead and check out that repository right over here. And if we go to tags right here, we should see that we just have this latest tag right here. And so that's going to be the tag that we use to deploy our container. So at this point, basically everything has been done from creating our Rust application, testing that Rust application locally, packaging up the Rust application into a Docker container image, and then, of course, publishing that container image up to the Docker Hub registry. So we're done as far as building our application and packaging our application goes. So now we want to go ahead and instantiate or deploy our application into AWS. So what we're going to do is switch over to the AWS Management Console here. And there's a little bit of setup work that we need to do in order to create our AWS Fargate service. So first, let me get signed back in right here. And now that we're signed back in, we can go ahead and do some basic setup work. One of the first things that we have to do is head over to the Amazon Virtual Private Cloud Service. This is basically your software-defined network in your AWS account that allows you to deploy things like containers and virtual machines in Amazon EC2, RDS instances, and a whole bunch of other types of resources. But if you don't have a VPC that has an internet gateway and allows you to basically attach a container with a public IPv4 address, you can use a template by going to the Create VPC wizard right here, and this will auto-generate a name here. So I'm going to call this StratusGrid as a prefix. I'll just choose a single availability zone because we don't necessarily need high availability for demonstration purposes. I do want to make sure that I have one public subnet though, because I want my container to be directly exposed on the internet with an IPv4 publicly routable IP address. I'm going to choose 0 private subnets here because I don't need any separate private subnets in this particular case. And then we can go ahead and just say create VPC. So this is going to create the VPC, the subnets, the route table, the internet gateway, and all of those basic things that you need in order to have a basic software-defined network in your AWS account so that you can deploy AWS Fargate containers. All right, so now that we've got that VPC created, you can see it in our list of VPCs right here. It's time for us to go ahead and do some additional setup work here. So the next thing that we're going to do is go over to the ECS service here, and we're just going to create an empty cluster. Now, when you create a cluster in ECS, you're not really creating any kind of compute capacity. You're not really provisioning any compute resources, but you have to go through this process of creating an empty cluster in order to have a place to deploy your Fargate containers. So we're just going to create a cluster here called stratusgrid-actix, and we're going to make sure that under the infrastructure section right here, that this little checkbox for AWS Fargate serverless is checked right there, because we do want the ability to deploy Fargate containers to this particular cluster. And then we'll just hit the little create button here in the corner. That doesn't really take too long to accomplish here, but now that we've got that cluster in place, we can go ahead and move on to creating a task definition. Now, a task definition here essentially allows you to define all of the parameters of your task or containerized application that you want to deploy using Fargate ahead of time. And then once you've defined all those parameters, you can basically instantiate it by deploying an instance of a task from this generic task definition. So there's a nice little wizard in here that we can use to create a task definition. So just click on the drop down here to create a new task definition, and we'll call this stratusgrid-actix for now. We'll make sure that the launch type is set to AWS Fargate. I'm going to keep the Intel AMD 64-bit architecture here, but if you choose to use an ARM-based container image instead as your base Rust container image, then feel free to use ARM architecture. We also need to make sure that we allocate enough RAM. If you don't have enough RAM, then your application might actually fail to compile on startup. So I'm just going to choose maybe half of a virtual CPU and 2 gigabytes of RAM. I did actually test this application with as little as 1 gigabyte of RAM, but I'm going to give myself just a little bit of extra breathing room here. Now, pretty much everything else can be ignored here except for the container itself. So under the container details, we're going to specify a container. I'll just call this like web server or something. You can really give this whatever name you want to, but the important part here is the image that we want to deploy. So the image is going to be the DNS name of the registry, which again is going to be Docker Hub, which is docker.io / Trevor STR, that's our username on the Docker Hub, and then we want to specify the repository name, so stratusgrid-actix, and then you can also do colon and specify a specific image tag or a specific version of the image that you want to deploy. So we'll go ahead and do that, and then under the port mappings for that container, we'll do port 18163 that we want to expose. That's a TCP port that's going to be connected to through HTTP. And I think pretty much everything else here we can leave as the defaults. And so finally, we'll go ahead and just click on the create button, which is right behind my head here. So we'll click on that, and that will create the task definition for us. So now that we've got the task definition created, we can go ahead and actually deploy or create a task on our AWS Fargate cluster that we just provisioned a moment ago. So we'll choose deploy and then run task, and then we can choose which cluster we want to deploy on. And of course, we already created this one here called stratusgrid-actix, so we'll choose that one. And then there's a few other options that we need to specify here. You can choose this launch type here, which allows you to choose either Fargate EC2, or you can use Amazon ECS Anywhere to actually run containers through ECS on on-premises infrastructure that you actually control. But in this particular case, we're going to be using the Fargate launch type. The other option you have here is to use the capacity provider strategy, which gives you the additional option to use Fargate Spot, which gives you a significant discount on your compute spend in Fargate tasks. But we're going to choose launch type Fargate for now, and we're just going to choose that we want the latest version of the Fargate platform, although you do have the ability to select a couple of historical versions here as well. Now, under the task configuration here, you can see that the task family, the task definition family, as well as the revision of the task definition that we just created. Of course, we only have one revision, but you could always change that task definition and have revision 2, 3, 4, etc. But we're just going to choose that because it's already hard-coded in there because we chose that task definition as our starting point when we kicked off this deployment wizard. We are just going to choose that we want a single task replica. And then under the networking section here, this is where we want to choose the Stratus Grid network, or VPC, that we previously created in the VPC service. Now, we only have one subnet, and that's a public subnet, so that means that our container will be able to get a publicly routable IPv4 address directly on the internet. However, in order to be able to access the application that's running on port 18163, we need to make sure that we create a new security group that has a rule allowing inbound traffic on that particular port. So what we'll do here is give this a name like Stratus Grid-actix as the security group name, and we'll say allows traffic for Stratus Grid-actix app. And then down here under the inbound rules, we want to add a new rule. So we'll just say I want a custom TCP rule, and the port range that we want to target is 18163. And the source we'll just say can be from any IP address. Of course, you could lock that down to a specific CIDR block as well if you wanted to be a little bit more secure. But in this particular case, we're not really exposing any proprietary information, so we don't really need that extra layer of security. Also, you want to make sure that public IP here is turned on because we're deploying into a public subnet, and we do want this Fargate container to get a publicly routable IPv4 address. Otherwise, we won't be able to access this application directly across the internet, right? So everything else here you can ignore. You don't need to worry about task overrides. You don't need to worry about container overrides as well, unless you want to add in some environment variables or override the command entry point into your container or something like that. So we're just going to go ahead and choose create here. And this is going to instantiate that task definition that we created earlier, which ultimately points to our container image that's hosted in the Docker Hub, and it's going to deploy it onto the cluster. So what Fargate is doing kind of behind the scenes is it's looking through all of its capacity that's currently provisioned, and it's going to find a host somewhere in an Amazon Web Services data center in order to schedule or place this particular container onto or task onto. And if you see down here in the list of tasks, I actually have one task that's in the provisioning state. It'll also sometimes sit in the pending state here a little bit while the container image is being downloaded by the physical host that's actually going to be running the container. But then we also have the ability to go to logs over here. And one of the great things about Fargate is that it integrates with Amazon CloudWatch logs. And so you actually get automatic log persistence by deploying your applications using AWS Fargate. So as soon as our application or our container starts up, you'll see that these logs get populated right here. And you can see that all of the dependencies, all of the crates from the Rust crates.io registry are getting downloaded. And then the container is compiling our application because our entry point is just that cargo run command. And then in just a moment here, we should have a completed compilation process, and we should see a log message that indicates that our web server is running, and then we can try to access it directly across the internet. So give this a minute or two to compile the application, and then we'll come right back and test it. After a few minutes of compilation here, you should see that the application has finished compilation, and now we get that message starting web server that indicates that our application is running inside of this containerized Fargate task. So we'll head back to the details of this task, and we need to test out this container to make sure that it's actually running properly. Down here, you'll see that we have a public IPv4 address for this task. So we'll copy that to our clipboard, and then we'll navigate over to that URL in our browser just to make sure that it's working properly. Of course, make sure that you plug in the correct port, which is 18163 in this particular case, and then we'll go ahead and do a /new_UUID. As soon as we load that URL, you should be presented with a brand new UUID, and every time that you refresh that web page, you should see that a new UUID is being generated by the Rust application. So hopefully this video has been helpful for you to understand how to start from complete scratch, install your Rust toolchain and software development utilities, as well as writing an actix-web application itself, packaging that up into a Docker container, publishing that to the Docker Hub registry, and then ultimately deploying that application using AWS Fargate to the AWS platform. I hope that this video has been helpful. Again, if you'd like to support Stratus Grid, you can head over to our website at stratusgrid.com and book a consultation with us today. Thanks for watching, and we'll see you soon.